Dielectric resonator, it started its journey exactly 39 years ago. So it is the time to celebrate the 40th year, and we are going to complete 40th year next year. And hybrid electromagnetic 101 del mode was the first one to work as antenna. But after that, in the last 4 decades, several advancements, new experiments, theories we have experienced. And today's presentation is basically on hybridization. It shows typically 4 different categories. So we are going to present that 4 along with the state-of-the-art developments. You see, it is 2002, that is almost 2 decades after the inception of dielectric resonator antenna, that the researchers thought of combining 2 different resonators, the wire monopole and DRA monopole together. Experimentally, a result was published or reported by a Canadian group in conference, and Professor Anter and his team in Kingston, Ontario, Canada, they did much efforts to find its potential. One article along with one US patent was obtained, and the bandwidth was obtained about 3:1. Personally, I got involved with this problem after that in finding out its physics. Interestingly, you can see that the combination of 2 monopoles, this is traditional monopole, this is dielectric monopole, which was proposed in 1993 by Monge et al. As dielectric ring resonator. But the combination gives you so beautiful response, the broadband response over a wide bandwidth. And their contributions are found to be due to monopole, due to DR, but the question is, who is going to contribute this central one? And that is the clue of this whole design, and the physics behind this is not too difficult. It is actually the reduced type monopole. And actually, the new design guideline and all new findings we proposed and we reported in the subsequent year 2006. And immediately after that, several variants of this ultra-wideband antenna or monopole type DRA antenna were explored subsequently. The question is, can we enhance it further? Answer is yes, because the clue is the monopole itself is resonating in its fundamentals and harmonics with the same type of radiation pattern. Now, the question is if we can hybridize it by DRA. And I'm giving you some examples that we explored subsequently. This is one where the monopole is loaded by a dielectric resonator, which is a composite structure of cone and hemisphere. Individually, one hemisphere and cone, they work together, and all this we reported as ultra-wideband monopole during 2006 to 2012. I'm showing you another interesting problem we solved, that the monopole height is reduced significantly. You see this 0.1 lambda. The technique is different. It is a composite dielectric resonators, cylindrical dielectric resonators having this combination. And you see their fundamental mode like this. The electric fields of the fundamental modes are basically oriented like this. But if you look from top, the net result is only the vertical components, and that is giving you monopole-like pattern. And the central probe that is working as another monopole. So their combination gives you these beautiful results. Now another kind, that is radiating slot plus DRA. During 2004 and 5, two different combinations or two different structures were reported. The slot itself is feeding structure as well as radiating structure. But one beautiful work was reported in 2010. You see, I have marked it the circularly polarized hybrid. That is, one single DIR is giving you circular polarization with significantly large bandwidth when it is of hybrid nature. The structure looks like this. It is the prototype, and the results are very interesting. Where particularly I will not mention that part, that axial ratio bandwidth is beautifully spread over large bandwidth. Another type is microstrip patch directly combined with DRA. Dr. Esele in 2001 first reported, and later on the complete report was published in Transactions in 2005, and the authors obtained beautiful input impedance pattern or input impedance behavior with sufficient radiation characteristics that I have also noted from their paper. Almost in the similar time, another work was very interesting where the central dielectric resonator central patch was combined with one dielectric ring. And it is mentioned that they are using one 5-del type of mode. It is difficult to realize that type of higher order mode in this type of structure. And this is for millimeter wave, you see. And I'm showing the results that they identified the patch, DIR, slot, and slot over the band. But our main focus is the dielectric resonator of dielectric ring. It is also radiating broadside at that frequency. This is the central patch. So that is the reality of this structure, the hybrid structure that worked nicely. A new beginning that we reported very recently, that is again a circular microstrip patch along with two cylindrical DIRs. I'm showing you its beauty of this subarray, that it is like on single subarray, where the subarray dielectric resonators are fed by the springing fields. And you may ask, what's the mode? Definitely its mode is not the fundamental 1-1-del mode. It is the higher order 1-2-del mode we have successfully used, and I cannot refrain from mentioning it's the first report what we did exactly 10 years ago, the first report of HEM 1-2-del mode for dielectric resonator antenna. So what's the advantage? You see, over the large band, moderately high gain we are getting. One is the patch, and next, the higher side, it is covered by the dielectric resonators with this higher order mode. The beauty of this subarray, I'm showing you two subarrays. One is a linear array where 5 elements are being fed, and one 2D array with this subarray where 6 elements are being used. But you see here, number of feeds, it is 2. Number of feeds, it is 2 only. But there is no intermediate space required. DRA and other structures, several investigations were done. In this investigation, you see dielectric resonator is excited, but along with this, and patch, additional patch is added to this. Here, the feed itself is resonating and radiating, and it is combined with this for our modern communication purpose. The major communication bands are covered with that. Here one example where dielectric resonator, I'm showing you here the single DRA. It is combined with one mushroom-like structure. That is one metallic structure, very bulky metallic structure. So it is not the resonant structure for any bandwidth enhancement or any kind of additional benefit. The benefit is in terms of its efficiency. The radiation efficiency is enhanced by this type of hybrid structures. I'm not going to make the structure details because in one work we are going to present in this session the structure where the cylindrical dielectric resonator is loaded by one simple ring, and it changes the scenario to use it effectively. A very efficient resonator, very efficient antenna and array. I'm coming to almost the close, last part of my presentation. It is the state-of-the-art developments. So one development we have noticed in 2021, last year. It is one simple dielectric resonator antenna realized by 3D printing technique, but it is combined with some metal. The purpose of this metal is to tune this structure, but it is giving you almost 22% reduction in weight. So one example of its fabricated structure is shown over here. The other one, it is partly done, and we are still working on this. It is a hybrid structure. The dielectric resonator combined with a cavity with superstrate loaded cavity. Why? The purpose is the dielectric resonator's own resonant mode is combined with the cavity mode, and we need to judge and justify which mode is good for us. And based on that, when we use this structure, we get some amazing results. The structure finally looks like this. The structure is a bit bulky, but giving you some additional features, that is steady, continuously wide band response and high gain close to 17 dBi. So with this overview and the state-of-the-art techniques, we expect more innovations, newer structures to come up in the future for real field practical applications.